Hey everybody, welcome. Thanks for joining us. Thanks for the intros there. I appreciate it. Izzy, good to see you. Eddie, good to see you. So we'll get started here. We've got a lot of information to cover, so we'll get started. So welcome to our 2024 IECC Residential and Commercial Changes. My name is Randy Plumley. I'm the Senior Manager for Building Performance with Spear. I'll be your presenter today. We also have a guest on here. We'll speak to him in just a second. But just a little bit of housekeeping. This webinar is being recorded. It will be made available afterwards. Of course, we're going to upload that to YouTube. And then it's also IECC continuing education available for that. You have to be present for at least 75% of the presentation. Within about 72 hours, you'll receive a course evaluation email from Kathy Lawrence. Just fill that out and send it back. And then you'll get your certificate for completion of being on our webinar for today. And we'll have the chat feature open and the Q&A feature open as well. But by all means, we're probably going to hold to the very end to actually take questions. So we'll get started with that. And with next, as we go through, I want to kick things off first, but we're going to introduce Jonathan Sanchez. He is the program specialist for SECO. He'll open things up with a code adoption announcement. Jonathan, the floor is yours, and I'll drive the slides.
All right. Hi, everybody. My name is Jonathan. I'm with SECO, State Energy Conservation Office, and I'll be working on everything that has to do with the code. So for today, this presentation, I want to announce that the commercial and residential code adoption process will begin, and we are posting a request for comments today in the Texas Register. And the request for comments will have a 30-day comment period, and we encourage comments from anybody who is interested in these codes. And I will drop the link to the Texas Register in the chat later on. And here's the timeline for the rest of the code adoption process, the preliminary adoption timeline. So first, SECO is considering the adoption of the 2024 IRC and the 2024 IECC. So right here, we're on step 2, the request for comments that have been issued today in the Texas Register. So from then, the comments will be forwarded to Energy Systems Lab, ESL, which is a Texas A&M branch, and they will consider the comments in their recommendation. And after that, SECO will consider their recommendations, and then we will determine whether or not to file a proposed rule in the Texas Register. And next, after that, we will file an additional RFC, a request for comments, based on that rule. And we will respond to those comments, and we will determine whether or not to adopt that rule that is filed on Texas Register. So this is basically the events that are coming up, and number 2, the request for comments that is today. And that is for the commercial and residential code adoptions.
All right, thanks, Jonathan. I appreciate that. And thanks for being on the call with us today. So just real quick, if you're not familiar with SPEAR, there's probably some new people that will joining us today. We are one of 6 regional efficiency organizations. So we actually cover Texas and Oklahoma to help with adoption, enforcement, and compliance of the energy code, including ASHRAE 90.1. We actually help with certification training. We can do in-person training. We can do webinars. We can do Zoom calls. We can help with adoptions with cities that look to adopt the third energy code, as well as I come from third party, so I kind of help navigate that. If there's cities that are not used to doing third party inspections, using third party verifiers, we kind of walk you through how that's going to work and how to actually marry those two together so you guys can get a good partnership going forward. So we'll get started. A lot of slides to go through. I'm going to go really, really fast. Like I said earlier, if you're late getting to the call, we're going to hold call or questions to the very end if there's time. So with the 2024, we're going to see a more of a 7 to 8% increase in energy efficiency. We previously had roughly about 9.3% on the 2021 from the 2018, and now from the 21 to the 24, we're going to see another 7 to 8% increase with energy efficiency. With that being said, real quick, Texas is a little unique. They did adopt with a House bill, they adopted Energy Star as a compliance pathway. According to the way Energy Star works, once a state adopts a new energy code, if they're going to adopt the 2024, which Texas hopefully will see that through, once they do that, I believe it's going to be a year from then, they're going to have to actually move to an Energy Star 3.3. I may be wrong on that without going through it. I have not been through the program requirements of Energy Star in a while. Currently, we're on 3.1 and 3.2. 3.2 is for tax credits. But once a state moves to a more stringent energy code, then Energy Star will move the needle a little further and you'll go to a different version, which is the 3.3. So we'll dive into the technical updates. Let's just start with big picture first. The 2024 IECC represents the most comprehensive residential update since the 2012, reflecting nearly a decade of progress in building science, technology, and energy performance. Compared to the 2015, there are hundreds of individual revisions covering everything from envelope insulation, air sealing, and the likes. This edition introduced a new credit-based performance structure. I'm going to back this up with saying I'm reading what the code book is being published as. It's not a final amended version of SECO. So that's what public comments will be open for. You guys can see what's going through here and what's in the book if you've not already reviewed it. And then you can use that to make your comments with that. But in short, the 2024 is designed to help homes become more energy efficient, more comfortable, better aligned with modern construction practices, and also help set a clearer path to net zero readiness. So just real quick, they always continue to update this. I just want to read through real quick. The scope on the residential side of it is we're going to do 1 and 2 family dwellings, multifamily that's 3 stories or less, group R2, R3, and R4. And that's all buildings with 3 stories or less. I do see Stephen has his hand raised. We're going to wait till the end unless you want to put the question in the Q&A, and then we can get started with some questions going through that. Thank you. And then, of course, the intent of this, it always just goes back. What we're really trying to do is just increase the safety, the cost effectiveness, the energy performance of the building. Code allows for both prescriptive performance-based compliance path while still encouraging innovative approaches. It supports jurisdiction in adoption with stricter codes, also has zero energy ready buildings. There may be appendices that some cities adopt. Most cities do not adopt those in Texas. Most of the time, a state or a municipality will update every 3 to 6 years, depending on their code cycle and what they want to adopt. And then, of course, this will, again, not override safety, health, or environmental requirements of any other code that's out there. So one thing that they addressed a little bit is they added some cities have already adopted this with their 21, but they added an additional inspection. So now we're looking at footing and foundation inspections. Now we're doing a framing and air barrier inspection. So we call that a pre-insulation inspection, looking at air barriers. And then, of course, we're doing plumbing rough-in, mechanical rough-in, electrical rough-in. They did just update that to say it includes things like solar-ready zones, electrification, generation, inspections that shall verify conduit pre-wiring if there's solar-ready zones that are there, and the electrical panel for that to be tied into if those things exist. It's not a requirement, it's if those things exist. And then, of course, insulation and fenestration rough-in inspection. Now that's a pre-drywall with insulation installed, and then you have a final that you're going to have your blower door or envelope testing done at the end of that. One thing they did add, which I was glad to see, they finally addressed, kind of given an outline of using third parties. So that section R107.4, it tightens up on how third-party agencies are defined and used for inspections and testing. If your project's using third-party agencies, for example, they're going to verify insulation, installation, air barrier integrity, duct leakage testing, envelope testing. The agency now needs it to be an independent of the builder, designer, or installer, must have the right credentials and the equipment needs to be calibrated on manufacturer schedules, and then also must have the qualified qualifications that are specified in jurisdictions or code official. The key takeaway there is for builders and energy code teams is start early planning of the inspections. Make sure third parties that you invite to any meetings when you're doing updates to your code that you're there, and if you're going to start using third parties, invite them to the meetings. Also coordinate with code officials and local inspectors or agencies for approval because the requirements are more rigorous in the 2024 than previous cycles, and it will take a good trained third-party eye or building official's eye that's been trained in energy code to do these inspections. So just some updates that's actually happened as well. Just real quick going through them. I'm not going to read all of them, but we do have one called substantial improvement. There's always questions of additions or remodels is I'm not doing a lot of improvements, but there's going to be a term where the building official is going to determine what is a substantial improvement and does it require it to meet the new code requirements of the code, of the energy code side of that. But We'll talk more about some of these that are on here. The first one, common walls have now been defined and specified in specific ways in the code going forward, so that's a good call. If you're not familiar with any of the newer codes, I know Texas as a whole is on the 2015. Most cities have adopted newer codes, but the climate zone map was updated in 2021 and still exists in the 24 going forward. There were a lot of additions around the country and changes. Climate Zone 1A was added to South Texas for the first time. And then counties like Dallas and Tarrant County moved from Climate Zones 2A to 3A. The U factor table and R value tables have been updated. These, as you can see, if you're looking on, if you ever go to the iccsafe.org, you can see in blue text, it's anything that changed from a previous code cycle. As you see here, everything about this table changed. They did actually flip. Climate zones are now on the left column on the far left, and you've got climate zones are across the top and components are down the left. That's opposite of what it has been in the previous code cycles. This mirrors what the commercial tables and how the commercial tables are set up. But you can also see a lot of the U factors have changed a little bit as well. Some have gone more stringent and some had more relaxed that's on there, but you'll understand where that came from a little bit later on today. The R value as well, those tables also, it's your go-to reference for component performance alternative. You're going to look at that and you can do each component is actually going to have to meet what's required in the table. This is just one pathway through the code. One thing to note here is the 2024 edition has some relaxed ceiling insulation minimums, such as example of R49 going to 38 in some zones. This helps with cost and affordability of construction, but there were other things added, which we'll see later on at the end of residential as to why that actually was able to happen. Second, explicitly calls out or mentions the continuous insulation option in frame floors, walls, giving designers more flexibility. So it's basically just used this part of that to look at each component to go through there. As I said earlier, they just flipped that. So just when you're looking at it, in my opinion, it's a little easier to read than what they had before. And then, of course, we have component performance alternative. This used to be the total UA. They've renamed it to component performance alternative. So this is introduced in the 2024. So what that means is instead of strictly satisfying each line item for walls, roofs, floors, fenestrations, you can now model the actual assemblies, compute the total UA, and then you can show whether or not that actually meets the proposed. The proposed UA is actually meeting compliance for that, comparing it to a reference UA. This allows you for trade-offs, just basically envelope shell trade-offs. It doesn't really include mechanicals. So for design teams, this means optimal cost and efficiency trade-offs by selecting components that better fit your flexibility of your building and construction. But it also means you need to do the calculations and modeling early and accurately to basically document the assemblies and then show demonstration and compliance for that. Then it gets into the inspection process, which now needs to be verified from the field. Attic knee walls, surprisingly, is just now drawing attention. In the 2024, they are defined as definitions. The short of it is it's just a vertical wall that separates conditioned from unconditioned. Historically, these assemblies have been overlooked and treated as typical walls. Now the code explicitly treats these as a major envelope assembly, applying insulation performance requirements out of the R value table or U value table if you're going to use that. That means that you can't skip these. They must be treated as such. For builders and designers, the key takeaway for that is in your attic insulation and framing, don't forget to plan these knee walls. Make sure that the framing layout, insulation placement, air barrier on the back side of the attic side of that, and it's trapped basically on all 6 sides, shows documentation on sectional on the plans, and make sure those details are compliant. So this helps avoid any surprises in inspection and ensures envelope performance is holistic. I can't tell you how many times I was in the field, you walk out, you look at a home, and the knee walls have not been addressed. There's no air barrier behind them. You're waiting for insulation, and then they got to go back and put an air barrier behind it after all of that happens. Planning early on actually helps set some of those things aside where you don't have a problem. Another one that became a little bit of a contingent at the last few years that I was in the field was starting to go back to truss framing on roofing members. This basically brings attention to this in the code. They define it, they talk about it, but when you have a single story with a bonus room, and now suddenly you've got truss frame roof members, and you've got a bonus room and you've got stairs leading to that bonus room. As you can see from this picture, the framing is turned on its narrow side, which means if you try to cover that with an air barrier and then insulate it, you cannot get the required R value in that wall. So as it says here, you're going to have, when you look through the code, it's got to draw attention to this, and they've got to frame these appropriately so they handle the R value required for your climate zone in those walls leading up into a bonus room or second story that's going to be part of your building envelope. Sunroom and heated garage insulation, they did start with that. The code explicitly calls out the sunroom, showing it if it's being conditioned, if the garage has got a heater being added, there's now specific requirements in a section, not on the table. You don't have to treat it like a normal above grade wall. You've got to just, there's certain things that you can do. And as you see here, most of it for ceiling insulation, you're looking at R19, and for wall insulation, you're looking at an R13. And also, the most importantly, is ensure that the boundary between the garage and the house itself is treated as an exterior wall. But then if the garage is heated, it's going to have to also have a little bit of attention to that for the thermal envelope in that garage. Design team and builders must include these spaces in your compliance reports as well. This is one thing I always show, but it's basically the easy checklist that's in the book. It's the table R402.5.1.1. It highlights how you meet insulation criteria and air barrier criteria specific to each component. This table can easily give a checklist to inspectors and third-party agencies to confirming all the insulation is continuous and in alignment, undamaged, air barriers exist, they're sealed properly, windows, doors are insulated, they're flush, they're flashed correctly, framing is free of major gaps and bypasses. For builders, include these sometimes they include these tables as part of their checklist in the field. Third party uses this table also to create a QA/QC plan. They make sure subcontractors understand the inspection criteria. Either the builder can teach them or a third party can do training. Show them these tables and say, hey, every single one of these components, this is how it needs to be handled. Before we get sheetrock covering these areas, we need to make sure that they're done correctly. This table is about 1.5 pages long. This is only just a short portion of it. But one thing we talked about earlier, the definition of common wall is defined, but now there is a specific call out in this table, which is common wall and double walls are specifically called out. And just looking at it, it says an air barrier shall be provided, air sealing at the intersection of building thermal envelope shall be provided. It's talking about fire resistant rated walls and how to be compliant with that part of it. So at least now they're addressing that. That again was an issue in the field with me doing townhomes and the like, is you've got these common walls that are added to that, and suddenly it's an argument of, well, that's not an exterior wall, that's something different. They've now defined it in the code and added it to the checklist table. Air-sealed boxes continue to be a contention in the code. I laugh about it because every single cycle they've updated this over and over again. Really, the end result is you either use a manufactured airtight box, and if you do, it has to be a NEMA OS4 tested. Same thing as using a can light, has to be ICAT rated and has to be rated as such to be air tested. But otherwise, if you don't use those, which most builders do not, they just have to make sure that all bypass of air is sealed. That includes electrical boxes on the ceiling, that includes wall and switch covers on the wall, that also includes what you see on the lower right is the communication boxes. These things, those white boxes you see should never be put on an envelope, outside exterior wall, or on a garage wall, because we're going to now, as a third party, going to require all those holes in the back to be sealed. That's hard to do, and we've also been told that it voids the manufacturer's warranty of the equipment inside because you no longer have ventilation. So it's best to just keep those boxes off of the envelope itself and the thermal boundary. Put those inside a primary bedroom closet or in an interior wall and just keep those off of the outside wall. So blower door testing, that also has remained the same for quite some time. This is, again, prescriptively. It changes in performance, ERI, and other above code programs, or not above code, but like Energy Star may be different. This is a prescriptive call out, as we see here. Climate zones 1 and 2 is now 4 ACH instead of 5. Climate zones 3 and 4 stays at 3. If you're doing performance in ERI, basically it just says all climate zones can no longer exceed 4 air changes per hour. And then, of course, we do have what's called the CFM, cubic feet per minute of the enclosure area. It's another way to read, not doing an air changes per hour ACH. It's going to actually now read a 0.22 is the requirement, but those things have dropped over time. It's a different way to get a building to comply with an envelope leakage test. So there are exceptions that are still there. This came in the 2021, but if you're not familiar with that, they've now addressed it to where dwelling and sleeping units that are attached like apartments, you can do 0.27 CFM, but that cannot be a guarded test. In other words, you cannot do blower door on both sides and just do the one in the middle, which used to be allowed by code. It's no longer allowed. It's going to be a standalone non-guarded test. And then lastly, any building or home or dwelling that's less than 1,500 square feet can now use the CFM per square foot of enclosure area, and it's the 0.27 is the requirement. No longer are you trying to hit an ACH. That's really tough to do in homes or buildings that are less than 1,500 square feet. Multifamily, they finally pulled in a sampling protocol. So this basically is unit sampling. It provides a balanced way to ensure quality without testing every apartment. The code requires statistically valid sampling. It says at the least of 7 or 20%, whichever is greater, and specifically calls out you have to represent floor, basically specific floor and unit types to make sure. As we read on here, we're looking at it and see it must include a top floor, ground floor, a middle floor, and then the one that has the largest enclosure area. And then where air leakage is tested, but it is greater than and exceeds that, it must be corrected and retested. Each time that it fails, we must add 3 more units to that sampling protocol, that sampling group. And then those also must be tested. Any building that has fewer than 8 dwelling units, basically each one of those will be tested. Duct system design, we've always had manual J, manual S required in the code, and in the mechanical code, we're doing sizing of from load calculations of manual J, we're doing sizing of the equipment with manual S. Now it's bringing in manual D. So now we're going to look at duct design. Is it designed properly? Really, as a building official or city plan reviewer, you're going to ask for that to be turned in and documented with manual J and manual S. You're going to get the manual D as well. So you're going to just basically review that and show that they've actually put it. No one's going to really expect you to try to figure out is it correct or not. It's if they're showing documentation that they've done the design, then we're hoping that they're meeting those design because they've been trained by organizations that help them know how to do these things. There's software out there that makes it super simple and easy to do. It is a little bit time consuming, but it's going to show proper airflow, proper duct sizes. You could, as a building official or a third party, walk out on site, look at the duct design manual D and say, well, that's supposed to be an 8-inch. I'm looking at a 6-inch. That's wrong. And that's where we'll start calling it out by saying that you have the duct design is not installed per the manual D that's been turned in for permit. So duct insulation has been simplified. Basically, it used to say like crawl spaces were one thing, basements were another, attics were another, but basically now it just says if you're inside or outside the conditioned space, everything over 3 inches need to be R8. Again, this is prescriptive going through the requirements, but this is still required by performance. Energy Star is different. We're not going to speak to that. And then, of course, ducts inside the conditioned space technically does not have a code requirement for insulation, but as you talk to most experts, they're going to recommend that you insulate them to at least an R6, but you will not find that in the code book, but that does limit the chances of condensation on ducts if you have them insulated inside a conditioned space, such as a foamed attic. One thing that, speaking of foam and how it's being addressed in the code now, is this actually explains any ducts that are listed as part of or inside the conditioned space. There are things now that are required to take place in walls, floors, and ceilings. I know with me doing inspections, a lot of times I saw ducts like you see in this picture crammed against the roof deck. I know we see fluffy stuff at the bottom, but if you could picture this being foamed, they're just going to spray foam around it. That's no longer allowed. You actually have to have at least an R10 between its roof deck and the duct if it's part of or inside the conditioned space. As it says here, or at least 50% of the prescriptive insulation of that assembly, whichever is higher. So if we're looking at an R13 in Texas, in the climate zone of Texas, or you're looking at and it's kind of in a vertical cathedral, or it's on a vertical wall that's coming down from the attic above. If you're foaming, you got to pull that duct away from the outside air barrier, and you got to put at least an R10 behind it. So you want to make sure those are done. You can't just foam around it and expect that duct to be up against an outer air barrier. Duct leakage allowance has changed considerably. It used to be much easier to say, well, it's 4 CFM per 100 square feet or 3 CFM per 100 square feet if the equipment isn't yet installed. Now there's a table to follow, and this table is based on multiple factors, including size of home, number of returns, and location of ductwork. For example, if you're looking at one and you say, well, I've got all the components are installed, the house is over 1,000 square feet, and I've got more than 3 returns, you've got 6 CFM per 100 square feet, not 4 anymore. If you look to the far right, this came from Energy Star. That's an allowance that says, well, if you've got a small duct system, and let's say your target is, if 4 CFM or 6 CFM is below 40, then basically you just have to hit 40 or less. You're not going to try to get to that 18 or 23 that I've spent hours fighting in the field with, trying to get those things down tight enough. Energy Star says, well, as long as you get to that 40 for that one system, it should be good. So code's now adopted that same methodology that just says, look, we can't chase pennies to save dimes, or whatever you want to call it, or chase nickels to save dimes. Let's just call it good and let's move forward. Trying to find 8 CFM is not going to make a huge difference. That also, in duct testing, it also multifamily applies, is the sampling protocol. Same thing exists. We're looking at 8 or more, must have at least a greater of 7 or 20%. You must have at least a sampling protocol that has tested units that include top floor, ground floor, middle floor, and then the largest dwelling. Same thing happens with, if you have one that fails, it's got to get corrected and fixed. Anytime you have a failure, you add 3 more. And then, of course, anything less than 8 units, you got to test every single unit. So that makes it easier for multifamily to address that part of it. That came from a commercial side of apartments, and now it's brought it into the residential side of apartments as well. So mechanical ventilation, all dwelling and sleeping units are required to have mechanical ventilation, because the highest ACH that's allowed by code now is 5. Anything 5 or less must have mechanical ventilation. So most importantly, each mechanical ventilation must contain automatic dampers that open and close when it's not in use. The mechanical ventilation must follow the section M1505 of the IMC, the International Mechanical Code. So that must also be looked at as well from that side of it. So from the 2018 going forward, starting in 2018 and moving forward, we now have a fan efficacy table for mechanical ventilation. So any fan that's used as its fan source for bringing in or exhausting air for mechanical ventilation reasons must actually hit a fan efficacy, which is CFM per watt, using this table. So looking at this at the very bottom, in the 2021, they added the air handler unit that is integral and tested and listed as part of the HVAC equipment. Any CFM must hit a 1.2 CFM per watt draw. So the third parties are going to have to test that to verify that it's being done. There are equipment manufacturers that can meet that, but it's very hard to do. And then lastly, all ERVs and HRVs and inline fans must be tested at a pressure of 0.2 inches of water column. So that's just setting the parameters of a third-party testing and how it's actually done. So mechanical ventilation testing was added to the 2021. It used to be on only an Energy Star requirement, and then code says, well, you have to have mechanical ventilation, but it didn't ask for anything further. In 2021, it now says it must be tested and verified to meet the ventilation requirements for each building. The testing must be conducted by a third party, must have a written and signed report of the testing results that is required, and then turned into the building official, or AHJ, to actually show that it's compliant to that part of it. The code is kind of lenient on what equipment do I use. It shows you kind of how to do the procedure as far as what's allowed, but it doesn't say use this specific equipment. So if I use what we see in the picture and an HVAC company uses a different manometer and or testing unit, we're going to have different results. So it's kind of one of those things where you kind of just have to lean on the third party of doing the right thing. If they say it is failing, then more than likely they have more accurate equipment that says it's failing. Those manometers you see there are $1,500 and are highly accurate as long as they're calibrated on the manufacturer's schedule. So that's something that you're going to have to address with the builders that are there when the third party says it fails. Same thing with the other two for duct testing and envelope testing. We also have mechanical ventilation sampling for multifamily, follows the same procedure, at the least 7 or 20%. And if you have one fail, I'm not going to go through that again, but it follows the same procedure where we're just doing the same sampling protocol for multifamily. And then, of course, intermittent exhaust controls for bath, fan, and toilet areas. This is something new as the requirement. So if the systems are designed to operate intermittently, which most bath fans are, rather than continuously, the code mandates that they must include automatic controls such as time switch, occupant sensors, humidity sensors, contaminant sensors. I'll mention this again. This is what's in the book. This is not what's been adopted by SECO. This is what's in the book. It's also important that if the fan is serving as whole house mechanical ventilation, it's not part of this requirement. But if they're standalone and they're not part of mechanical ventilation, most of the time it's not in most of Texas, then it's going to have to follow this as well. So from a design and compliance standpoint, this means verifying whether the exhaust truly is meeting intermittent. If yes, then it must follow controls. Coordinate with the equipment selection, ensuring wiring and commissioning supports automatic shutoff, and then document the control type for inspection. Gas fireplaces, I think this was addressed in earlier codes, but they've now updated this again. Basically, we just say that gas fireplaces cannot have a continuously burning pilot light. This wastes energy when the fireplace is not in use. Instead, it must have an on-demand and intermittent ignition or otherwise similar equipment. Additionally, the fireplace needs to be vented. It also now must follow a fireplace efficiency rating. This ensures the homeowners are using the fireplace, or when they're not using them, that it basically meets energy performance when it's on standby, the way it's being done. So for design teams and builders, you should specify the ignition type and review the fireplace's listing and manufacturer's data to verify the FE rating is being submitted with the permit and also meets compliance for the energy code. Lighting equipment, it was easy to say, well, 100% high efficacy lighting was what was required. They've taken that out. They've now identified it as permanently installed luminaires shall be capable of operating at an efficacy not less than 45 looms per watt. And then, or shall contain lamps, not the fixture, but lamps that actually are 65 looms per watt or greater. There are exceptions to that. It's kitchen appliance lighting that's installed by manufacturer, antimicrobial lighting, general service lighting that complies with DOE 10, and then luminaires with a rated input not greater than 3 watts. So that's something you got to look at. It's no longer just saying high efficacy, 100%, or all of that. It's now got to just follow a looms per watt in that part of it. So, but they did add this. This is kind of more of a multi-family apartment style, but it says where total lighting power, we now have specific sections of the building for exteriors that say that now instead of wasting energy on the outside with the lights staying on during the day, there are specific call outs for the area of exteriors that now must follow a watts per square foot. So again, this is multifamily, or attached style townhomes that have a common setup for outdoor lighting is based off of one switch or controller and not just done by the individual homeowners. It also sets the base at 280 watts for exterior lighting. Also with exterior lighting, this basically is connected to the electrical system for residential. The goal is to ensure efficiency lighting and reduce unnecessary use at night. Exterior lighting must follow a specific section of the code, which basically puts the rules on the power allowance, the controls, and the efficiencies. However, there are still some exceptions for detached single-family townhomes and small R3 buildings with less than 2 units. Of course, solar power lighting and fixtures with motion sensors are not going to be required to be following this. The main takeaway with that is, with exterior being a large part of residential buildings' electrical system now, we must make them efficient and use controls to lower energy consumption, but also give flexibility for safety as well for exterior buildings. This basically is looking at part of the group is defining how much power is being used for outdoor lighting, so flexibility. I'm not going to run through every single section, but if you wanted to look at the lighting requirements, the actual power, and then the allowance of each section, and then the additional lighting power, and then gas lighting, you're going to see those are equipped with that, and you can read those specific sections. Interior lighting still has controls attached to it. A lot of people, or a lot of jurisdictions don't really enforce this or have this as part of their code, but it is in the code book where you're using interior lighting controls. So all permanently installed fixtures must have either dimmer or automatic shutoff controls. For habitable rooms like living rooms, bedrooms, dining rooms, dens, the controls must be able to dim the lights or automatically turn them off within 20 minutes after an occupant leaves. For non-habitable spaces like garages, unfinished basements, laundry rooms, utility rooms, the light must shut off automatically within 20 minutes. They also must still have a manual override option, but then it should also revert back to its schedule on its own without having to have a manual switch being switched to go back to its automatic sections. Exterior lighting, we're still on to that, talking about it a little bit, but this goal is basically to prevent unnecessary time at night. It basically, as we just said a minute ago with the other one, is if you have an override manual switch, the switch also must have something that goes back to its originally scheduled program to actually revert back to saving energy and not coming on at night. So if you override a sensor for some reason, it should have the authority and the availability to go back to its original programming. So simulated building performance, this used to be what we just called the performance path. They've renamed it again. It's the simulated simulated performance path. Looking at that part of it, they did tighten it up just a little bit, or they keep addressing that. But what if you notice here that's different? It used to say the UA, total UA. Now it's the total TC, which is building thermal envelope, thermal conductance. It's another way to read the energy moving in and out of a building. So now we're looking at 1.08 times the TC is what you're doing for climate zone 0 through 2, aka I just like to put it can be within 108% of the prescriptive reference design. The other one is 115% of the prescriptive reference design. And then of course the area weighted average maximum SHGC for climate zones 0 through 3, which covers most of Texas, that SHGC is 0.30. So this approach gives flexibility, trade-offs between insulation, glazing, HVAC, using performance. The majority of builders that I know in Texas use performance, not prescriptive. Common modeling tools to use is ResCheck, rim rate, ecotrope, energy gauge. All of these are DOE approved methodologies and should be approved by AHJ or a jurisdiction having oversight to compute compliance for that. But I'll just caution you with every single one of these softwares will have a different result or different output. Their engines behind it they're built on has been tweaked a little bit, and so a lot of times they will have different outcomes. Overall, you still need to show compliance, and most cities will say all of these are acceptable as a compliance software tool. And then with that part of it, though, it starts to slide. This slide basically breaks down how the energy cost targets are determined under simulated building performance. So if you're looking at this, it's talking about fuel burning appliances. So if a home is using a fuel burning appliance, aka a water heater or a gas furnace, basically what we're looking at is the proposed design must show at least a 20% reduction in annual cost. Before we had that's a different figure that we're looking at, but now we're looking at 20% reduction in the annual cost. The software will show you that. For homes that are all electric, you're looking at a 15% reduction. They're starting to, what most people would call a penalizing of a large building. So anything over 5,000 square feet, the code now requires an additional 5% reduction. So if you're using fuel burning appliances, it's no longer a 20% reduction, it's a 25% reduction. You're adding that additional 5%. This accounts for the overall energy impact for that. In short, of course, the building performance path doesn't just look at insulation and equipment. It now focuses on a total annual cost of energy, rewarding designs that use less overall energy, regardless of how that savings is being achieved. So performance is one of the easiest and least costly pathways to get through Texas code. There still are performance mandatory from the 18 prior versions of the code. There were sections that were listed as mandatory. That has now ceased to exist. It's now a table of mandatory items. So if a builder chooses to use performance path under the R405, basically what you're looking at is this is the requirement you're going to have to do. And anything that you see in blue has actually been adjusted from the 2018. But that doesn't mean that you can skip these. You have to follow that. That includes measures like air sealing, duct testing, vapor barriers, whether that's in your climate zone or not, proper installation of insulation. And then, of course, performance model can trade off between systems, but these are core elements that are non-negotiable. They ensure the building's envelope, mechanical systems, lighting still meet the baseline energy code requirements before the model is approved for compliance. There's also the ERI, which a lot of people still use, and they can use in Texas. Some of them are tied to an incentive program. You have to show either an ERI or a HERS score. So it's one of the most flexible ways to comply with the 2024. Instead of following every prescriptive installation and requirement of the code, they see you're just modeling it to try to get a performance score. That score is from 0 to 100. A score of 100 is basically a 2006 IECC baseline code. If you get a home that's a 0, basically it consumes no energy or it's net 0. It's basically has on-site generation that offsets consumption. The lower the score, the better the efficiency. Of course, each climate zone has its own ERI target, and we'll talk about that on the next slide, or the next couple of slides. We'll see that in just a second, but it still follows a mandatory item like this. Just like in performance, we have an ERI mandatory list. Some of these are a little bit different than performance, but most of them are the same. You're still following air sealing, insulation, duct testing, ventilation, efficiencies. You're still doing all that. The goal here is to ensure that the home is modeled through software and that the ERI passes maintain a solid foundation for efficiencies and then allows for trade-offs. But as you see, and as we said a second ago, the things in this list are non-negotiable. Every ERI homes rated must qualify for compliance, must meet these mandatories. With that part of it, though, so the 2024 makes sure that the using these performance paths like ERI or credits, the building's thermal envelope, the walls, the ceilings, the windows, the doors meet a solid baseline. So you can trade off any of these. You can't trade off any of these entirely, but you can just trade some of these off for less stringent or less insulation that's required. So the insulation, air sealing must meet or exceed the prescriptive minimums, outlining that the intent here is to prevent homes from using high efficiency equipment or solar panels to mask a leaky or poorly insulated shell. So before any trade-offs or credits are applied, the envelope itself must reach minimum performance, as we see with this. And then the ERI, we talked about that a second ago. The table you see on the right-hand side top is what's out of the book. What we see on the lower right is what Texas adjusted by House Bill 3215. So as I'm saying this and going through it, the top table is what's in the code book. Right now, Texas has the House Bill 3215, which adjusted it until September 1 of 2031 and that part of it. But right now, we're currently in the third adjustment for the timeline, which puts climate zones 2 and 3 at 57 and climate zones 4 at 61. As you notice, climate zone 1 was not part of the code or in the code, or Texas did not have a climate zone 1 at the creation of the House Bill 3215. So that's another kind of a question mark as to whether or not that's going to be, I'm sure people will just look at this and say, well, what's climate zones 2? And then we'll just try to pick the same ERI or HERS score to meet that compliance. With that, this is what we were talking about earlier. So prescriptive, as we saw with prescriptive R table and U value table, U factor table and R value tables, you're actually seeing some of the attic insulation drop. This is kind of why they were able to do that, is because they added a section R408, which is called additional efficiency requirements. So even though you've met a prescriptive level of what you see in the code and you're looking at that table, only prescriptive, not performance, not ERI, you're doing prescriptive only, then you also have to go into this table, which is R408. You must pick a minimum of 2 options, and then you've got to total up 10 points. So with this part of it, now you can use, instead of prescriptive single method, it allows builders to choose efficiency upgrades such as insulation, improved HVAC equipment, renewable systems to earn required credits. So each measure is assigned point values per the climate zone, and then the numbers of credits are dependent on the climate zone that you're in. And then this approach promotes cost-effective compliance and rewards builders for integrating high-performance features into their home. So if you have a home that's built as standard construction today and it's R13, but you've made it a choice to go with a 90 plus AFUE furnace or a high SEER equipment because you're marketing yourself as a very high efficient builder, well, then this is allowing you to actually take credit for that. So you might can look at prescriptive and use credits to get there instead of using an overall performance model or an ERI. So it's going to take a third party can run the numbers for you and determine whether or not one's better for you or the other, depending on the cost of construction. So you can make that determination. But they've added this credits table to that. This is only a small portion of the table. It's 2.5 times this length, and each one of them have assigned credits in there. This is probably something that those credits will be adjusted every cycle from time to time. So credits may adjust between cycles depending on where you're located in Texas and what city. With the additional efficiency requirements as well, though, we have, as I said a second ago, and we talked about it a minute, but if you have homes that are over 5,000 square feet, now we're getting, I need an additional 5 points. So if you're already picking 2, but the house is 5,600 square feet, I need 15 instead of 10. So each measure is selected for the relevancy for that, and then you receive credit for that part of it. The software modeling that you do, ResCheck, Ecotrope, rim rate, energy gauge, all of those are going to have a section in there that says which options are you picking. If a city or jurisdiction decides that they're not going to adopt this and they're going to delete it, just know that when a ResCheck or Ecotrope report's turned in, it's going to require us to select something. We can't just not do it because it's going to say you're not compliant and it will not show a passing model. So just know some things are going to be picked. Even though you're not requiring it, they're going to have to pick it to get a passing report. So that does lead to some confusion from time to time. And then I'll just quickly go through a couple of slides just to bring some highlighted sections up in existing buildings, chapter 5. Most cities either do or don't reference this, but just part of it is there is also efficiency credits and in additions that are on here. There's also building thermal envelope things that need to be met. Heating and cooling system also now needs to be sized per manual J and S if it's being completely replaced. And then, of course, there's efficiency credits for substantial improvements. As we said earlier, that's defined now in the definitions, but it will also be up to a building official or the AHJ to say what is a substantial improvement and do I need to now enforce the code as not just being a repair, but it's something that needs to now meet new code requirements. So with this on here, new heating and cooling duct systems that are part of the alteration shall comply with R403, which is now sizing of the equipment and following Manual D duct design. Alterations in heating and cooling must also comply. There is an exception, of course, if you're tying into ductwork already there, the existing ductwork does not have to comply, but anything new will have to comply to that. And then ducts with that, as we just said a second ago, is the HVAC newly installed part will need to actually follow R403, which is new. And then anything after that you cannot get to, or you cannot, or you will not be changing out, then basically it can just be added to that as an extension for the addition. I just said this a second ago, but manual J, S, and D are required for sizing of equipment. Of course, that's also going to be determined on if the contractor's pulling a permit. If they are, cities will have authorization to be able to say, look, it's a complete change out. I need you to do manual J, D, and S and get those turned in for the right sizing, because the home could be going through improvements like more attic insulation, better air sealing. They're going from a blown attic insulation to a foam encapsulated attic. They're putting in better windows. They're air sealing the envelope itself. That does change loads in the home, which will change sizing equipment of the size of the equipment. And it will also change duct design as well, lowering the sizing of the duct to that system, because the systems itself will reduce in sizing. So you have authority to do that. And then, of course, duct testing, anything that's 25% or more of registers have been replaced, 25% or more of all ducts have been replaced, the total length of ducts been increased by 25%, you can require a duct test to be done. I think there's one city in North Texas that actually does require that on all of them that have a permit that's pulled. But it's 12 CFM per 100 square feet, not the new requirement of 4 or 6. It's going to be 12. That's still pretty tight, there's existing homes out there that are probably over 20 to 25% and even higher on duct leakage currently. So just making sure that you have those things tested and they're meeting at least a 12 CFM per 100 square feet or less is going to be part of the existing. And there are appendices that were added to the code. There's net zero energy. If you have a builder wanting to do that, there is appendix that you can adopt through the city, or a city can adopt that. There's electric ready storage. There's all electric buildings. There's alternative building thermal envelope insulation R value option, which I think is going to become pretty popular. Once you start reading and looking at it, you'll know why. Sometimes that can make it a little easier for a builder to build energy efficient buildings, but not have to go to an extreme by using this alternative building thermal envelope appendix. So with that, that's pretty much residential. I know there's a lot of questions that are in the chat and on the Q&A. We will get to those, but we've got a lot more to go, and I'm just going to keep burning through this. And when we get done, if we have enough time, we'll open it up to questions. So for commercial, same thing with this. Significant modernization for that. So major updates for envelope from design, lighting, HVAC, building controls. They've expanded the scope and clarity of that with hundreds of revisions. They're merging, kind of, in my opinion, merging back to be more in line with ASHRAE 90.1 instead of some of the requirements being completely different. And then there's builders or developers are picking part of ASHRAE 90.1 and part of the IECC. They're kind of merging those back together to make a more cohesive energy code for multifamily using the 90.1 or the commercial side. And then performance credit option also adds flexibility, points-based path, rewards higher performing systems, renewables, and then grid-friendly designs. It focuses heavily on efficiency. It strengthens in-use or energy use targets to support pathways for load management and renewable readiness. So the scope intent, I won't read all of this on here, but the big takeaway from that is cost effectiveness and marketability must be considered for each measure. Overall efficiency must increase with every addition of the code. The zero energy building compliance pathway must be included. An option for zero energy buildings by 2030 must be included. Greenhouse gas reduction measures are also in part of that. Additional appendices to help jurisdictions meet energy efficiency goals. And then code updates as well every 3-year cycle, same as residential, it always does that. But the intent remains the same, where it's flexibility for particular use of innovative approaches, techniques, and technologies that demonstrate compliance. One thing that they did change a little bit, they added some things to what's now supposed to be included on construction documents for plan review. We've got thermal bridging. They want to identify, that's a slide a little bit later, we'll get in more detail. But things like that is tell us where all the thermal bridging points are and show those details on your plans. Those things need to be on there that include balconies, floors, cladding supports. Locations of pathways for routing and raceways for cabling if there's on-site renewables being used. Location for reserve for inverters, metering equipment, energy storage, anything that's being done like that is we need to see this on the plans. Location and layout of designated areas for ESS. And then, of course, rated energy capacity and rated power capacity for installed for the energy storage systems. I won't read through all of those. There's a lot of new definitions that have been added to that part of it. Again, in commercial, it says substantial improvement. That's going to be up in determination of how much improvements are you doing. And does that now fit into a new code requirement as opposed to just it's an addition and it's not a lot of it's being done. Methods for determining, this has been a little bit adjusted here. These sections include, I won't go through all of those. You can go through each one of them separately. But now we're picking out specific sections of tapered and above deck insulation based on thickness, mass walls, area weighted averages, spandrels, cold forms, steel assemblies, mechanical equipment penetrations. All those things are being addressed in when you're determining the U, the C, and the F factors as well. Component performance method, there's still one of those similar to the residential side of that. It provides an alternative for compliance pathway for building envelopes. It uses the U factor and the F factor trade-off methods, allows for trading higher insulation on one component and lower on another to still meet an overall performance. Must have by the approved calculations and modeling to show equivalency. So you're using a COM check or something that's similar. Other designs Offers design flexibility and potential cost savings while maintaining total envelope efficiency as well. Air sealed boxes, same thing as residential. If you use air sealed boxes that are manufactured to be airtight, then it needs to follow a NEMA OS4 or NEMA OS4. If not, they need to be air sealed to the envelope itself. So whatever means that you have to do, either putty packs or poly seal or fire caulk or gaskets or combination of all the above, you've got options to do one or the other. They made it clearer in the 2024 than it has been previously, but these things need to be done when it penetrates the envelope itself. So air leakage testing for commercial building was broken into sections allowing for options and must be tested by a third party, approved third party. I won't go through the whole detail of that. It is lengthy for that part of it, but it's also based on size of the building. We're looking at a different pressure reading, which is 75 pascals, not 50 pascals. It's 0.35 cubic feet per square foot of the enclosure area, not an ACH. We're going to look at dwelling and sleeping units like apartments, envelope design and construction verification. Of course, there is a sampling protocol. That's where the residential got this from. But it just goes to show you'll have to read the details on what size is that building and what are you actually going to do and what are you required to do with that part of it. There is whole building testing and there is now sectional, or you're breaking the building into sections or chunks to do the testing. So thermal bridging, we talked about that earlier, is now it's addressed in the code that says there are specific sections based on where those sections or intersections are: balconies, floors, decks, cladding support, structural beams, vertical fenestrations, parapets. All of those are now listed in there to say, show us where these things are. Of course, as you see, the exception, if the building's located in climate zone 0 through 3. So the majority of Texas may not have to put those thermal bridges in your report, but climate zone 4 and above do. Any material with conductivity that's greater than 3 BTUH per square foot is going to also be accepted or be exempt from that. And then thermal bridges accounted, but are already accounted for in the U factor or the C factor calculations, are also exempt for that as well. So mechanical sections with this is actually introduces mechanical requirements for commercial building, which there already were some, but it changes it up a little bit. It basically is any equipment that provides heating, cooling, and ventilation or refrigeration must comply with mechanical provisions of the code. Most buildings on here are going to follow the C40311 and 403.2 through the 403.17, which outlines all the efficiencies, the controls, the ventilation, the equipment of the performance of the equipment. But they've now started to address data centers in a different category. So data centers have slightly different paths due to their unique cooling demands. They have different sections that are in there for data centers. And then section 409 can be used for energy monitoring and advanced efficiency requirements as well. The goal here is for this section to ensure that commercial HVAC refrigeration systems operate efficiently and are properly controlled and meet minimum performance standards aligned with today's technology and energy expectations. This was, again, addressed in this code. They've clarified some of it. It was in an earlier version of the code. But basically, we're talking about like roll-up doors like you see here. This is a restaurant showing a roll-up door. So this applies to any commercial spaces that has large operable openings to the outdoors, such as restaurants with garage door style openings, event centers, bars, retail areas with open patios. The goal here is to prevent heating and cooling from running to the outside when the building is basically being conditioned and open to the outside. It's a waste of a lot of energy. So if the operable door or opening is larger than 40 square feet, which what we see here is, basically when that system is running and the door is open, it responds within 5 minutes. It will adjust the thermostat. If it's heating, it's down to 55 degrees. If it's cooling, it goes up to 90 degrees. Cooling can remain on if the outdoor temperature is lower than the indoor temperature, allowing for free cooling. Basically, it's running, but yet it's cool outside like it is today. There are multiple exceptions for that, such as healthcare facilities, certain industrial uses. The simple idea here is basically if the building is open to the outside, the HVAC shouldn't be fighting against the outdoor weather. So that's being addressed and reclarified in the code from time to time. And then humidification and dehum controllers as well. This section basically prevents waste of energy caused by unnecessary or excessive humidification or dehumidification. So first, dehumidification, the code restricts mechanical cooling from driving humidity down too low. And then humidistatic controls can reduce humidity below a dew point of 55 degrees or below 55 or 60% relative humidity in cold climate zones unless cooling is required for temperature control. This prevents overdrying of the space. So once it's at that level, then it won't come on and dehumidify. For humidification, which isn't really used a lot in Texas, the code prohibits the use of fossil fuel or electric resistance heat to raise humidity above 30% relative humidity in warm climates. This avoids waste of energy by the added moisture that's rarely needed. Finally, when a system has both humidification and dehum capabilities, controls must be interlocked as the two systems cannot operate at the same time. It's critical, otherwise one system can't add moisture while the other one's trying to pull it out. That's a huge waste. So overall, this section's purpose is to keep humidity control in a reasonable, efficient levels. There is now also demand control ventilation. So this section introduces the DCVs that must be installed. These are smart ventilation strategies that adjust for outside air based on actual occupancy, sometimes based on a CO2 sensor to avoid overventilating when the ventilation isn't needed. Under the 2024, it's required that certain spaces served by a single system, when an air side economizer is included. So the idea basically is avoid bringing unnecessary outside air in and conditioning when only a few people are present. So there are exceptions for that, such as spaces where ventilation loads are minimal and where other control methods are already being used. Overall, the DCV is basically about is balancing comfort, indoor air quality, energy efficiency, ventilating when the space fills up, and then scaling back when the actual space is empty. And then occupied standby controls. This goes basically hand in hand with lighting control sensors. The idea is simple here. If the lights turn off because no one's in the room, the HVAC should also be adjusted as well. So under this section, any zone that requires lighting occupancy sensors must also have HVAC controls that switch into an occupied standby or unoccupied standby when the room becomes empty. So in that mode, the system reduces energy use by doing two things. First, it sets back the thermostat. And then secondly, it also is either shut off or reduces air supply or supply airflow to that zone. This requirement ties in ventilation as well as HVAC operation to occupancy rather than just running continuously. So overall, this creates smart, more responsive control strategies, keeping the occupants more comfortable when present and then saving energy when they're not. There is specific requirements now. This used to be a contingent in the code of if you're looking at ventilation fans, but now we have something called a low capacity fan. There's now a specific section for that. It's dedicated to where these are not exempt from efficiency or controls. It ensures that the smaller units still incorporate automatic controls such as shut-off ventilation when demand is reduced. It also reduces the fan power limits. This basically helps maintain energy efficiency for smaller equipment instead of just tackling those large units that we see. So something that falls outside of the parameter of what's called a large ventilation system still also now has a specific requirement section. And they've also addressed this as well. So if you have something like this, large diameter ceiling fans. So rather than just letting large fans operate unchecked, the code basically mandates minimum efficiency or power limits. This means for big open spaces with these big fans like gymnasiums, factories, big box stores, things like that, the equipment selection and controls must comply with energy code exceptions like HVAC or lighting as well. So this is also still going, it applies to anything 84.5 inches blade diameter span or greater, and then it's required to meet specific performance requirements. Dehum for spaces on plant growth and maintenance. This is something that's coming up now where we're getting indoor agricultural buildings to actually grow some of our food, but these spaces now are being addressed as plant growth. They have unique humidity control needs, so the code now gives multiple paths for compliance, either by a certified standalone dehumidifier or systems integrated with heat recovery that capture reheat energy, or other type systems where low dew points are required. The key takeaway here is basically even in specialized indoor agricultural zones, the equipment must meet defined performance criteria aimed at reducing energy while controlling moisture at the same time. So it's a big balancing act for those kind of systems that are there. And then there is now a specific section for clean water pumps. It basically introduces this efficiency in the 2024, where these basically circulate water without particular content, basically like not wastewater, it's not processed fluids, it's what's considered clean water. The code now requires it to be defined as a PEI value of less than 1 to ensure they operate efficiently. So this closes a gap that were previously open where these pumps were not exempt, or were less regulation, or they had been exempt and there was less regulation. For building designs, basically that means that mechanical systems that include booster pumps, heat pumps, or water loops or water chilled primary pumps need to be selected with verified efficiency metrics, just like HVAC fans or chillers. Make sure when specifying these pumps you check the PEI and confirm data certification or labeling that will actually meet the code requirement that's there, because that should be checked on a plan and review. High input service water heating systems. This one basically services on those large capacity water heaters. So for large multifamily that's all tied together, hospitality, other things like that, rather than using standard performance values in C2 404.2, these larger systems basically will meet more stringent criteria and use advanced technologies. So the idea here is to avoid a situation where scaling up the load means accepting lower efficiencies. For designers and specifiers, if your hot water plant input is high beyond typical domestic scale, you need to check section C 404.2.1 for specific compliance paths. Still staying in line with that for service water heating is 404.4 mandates that service water heating piping, both hot and chilled loops, must be insulated with specific and minimum insulation to minimize thermal losses through those pipes. This ensures basically that those pipes, piping between the heater and the fixtures or circulation loops are not neglected, and that the efficiency of that is maintained. The code also includes a dedicated table C404.4.1 for insulation thickness and clarifies piping inside conditioned space or buried in different settings. And then the demand responsive lighting controls function. This still continues to be clarified or adjusted. So basically in this, the 405.2.8.1, in buildings where this is adopted, the lighting systems must be able to receive a demand response and rapidly reduce power to less than or equal to 80% of the full output. In the 2021, I believe that was 50, now it's 80. Within 15 minutes of the signal, once the event ends, the light turns back to automatic power. Or being automatically controlled. Its strategy here basically is to integrate lighting with grid management efforts, helping buildings participate in energy demand reduction programs while also maintaining occupant functionality. So because of its basically enhanced controls, its key for performance is basically you can also use this in seeking credits on some of the projects that you do. You can, depends on how much you go to, is you can get credits for this. And then lighting and switched receptacles for sleeping and dwelling units such as apartments. Basically, it ensures that these units within the commercial buildings, lighting and receptacles that are on the switch are under a control and reduce plug and lighting loads when it's unoccupied. It mandates foundationally the electrical switching infrastructure. So it's about managing plug load and lighting in spaces that are most of the time overlooked in the commercial compliance. What you see here, I actually took this picture. This was in a hotel in, I think, Washington State. They met the requirement by installing the sensor, but then they made cute little pictures that they stuck in there that they can just leave it there and it was not pulled out by the occupant. So they just, when you left, it just remained on. This is something that they're trying to get around, is to not have this happen where it's unoccupied and the lights and the plugs and the HVAC is run uncontrollably when no one's actually in there. And then, of course, we're addressing now more even of we did it with HVAC. Now the lighting is horticulture lighting. So it's often sometimes a large part of energy use for indoor farming or greenhouse environments. So we're looking at that and they're bringing it into the energy code itself. So it mandates that high efficacy lighting and automatic controls such as daylight, shut-off, time switches, basically that in specialized plant growth facilities, the energy consumption is going to be addressed. So you're going to look at some of that for designers and owners in architectural or indoor cultivation areas. This means verifying PPE ratings and ensuring basically proper automatic control and device integration beyond simple selecting high wattage fixtures. So you're looking at the power consumption of that. If it's the greenhouse itself and not the office, you'll have a different allowance for power lighting that can happen within that section instead of it being, and it's going to be different than from other sections of the building. So that's going to be in the code book as well. And then energy monitoring, so that it continues to tighten up requirements for energy monitoring, lowering the building size threshold from a 25,000 square foot to a 10,000 square foot. This means a much wider range of commercial buildings will now must install metering or monitoring devices that capture energy use by the basically usage by end use. And that's going to be including of HVAC, lighting, EV chargers, things like that. Importantly, the code experts that expects this data to be available in a usable format, hourly or better, and enables benchmarking, performance tracking, and operational optimization. So for design teams and owners of buildings, the early coordination with metering architect, such as the data collection system, what are you going to use, the reports, the dashboards, the integration of that, how is it going to be connected, and who's actually going to be the team that runs that, is going to be a required element for compliance rather than just optional. And then, of course, renewable energy systems, a little bit of that, making renewable energy a formal part of the code itself rather than simply optimizing building loads. Buildings now are required to provide a minimum amount of on-site renewable electricity. Again, I'll reiterate with this is just what the code was published as. This is not a final amended code section. I'm just reading to you what the code book is. So making the code more than just passive efficiency, it's going to start pulling in things like PV systems, things like that. But we're looking at this for design teams. You're going to look at structural and roof supports, integrating building electrical systems as part of the code compliance. And then with compliance with that, there's also a credits-based additional efficiency path for the 2024 IECC. So instead of just meeting the minimum prescriptive requirements, commercial buildings now must earn a defined number of credits by selecting from a menu of efficiencies and load management processes or measures. This encourages basically early integration of design decisions. So you'll need to pick what the credits on your projects pursuing, ensure that they're documented, and verify that the measurements are being performed. It's part of the shift here is purely component by component compliance to system and performance awareness compliance. Instead of just picking each component, they're now looking at it from a performance holistic aspect. And then additional efficiency credits as well. So 406.1.1 shifts commercial compliance toward a credit-based systems. We just talked about a little bit of that, but you pick these measures off of that. It's based on building type as well. For your project, if it's mixed use, then you're going to calculate a weighted average of the requirements. So small or exempt buildings types may be treated also differently. And C406.2 basically is your menu of energy efficiency options. So basically pick what makes sense for your project, earn credits accordingly. These measures range from better insulation to HVAC efficiency to advanced metering and lighting controls. Credit value, of course, depends on how much better the performance is based on when you're referencing your baseline. And then you may be able to do several measures to hit your target, may have to actually be needed. And then it gives design teams flexibility while demanding a holistic whole building efficiency approach. And then adding additional renewables and load management credits there. There's also significant areas here where you're talking about using renewables or load management. There's a different table here for credits that are on that. I won't go too deep into that part of it. But for project teams, this means identifying renewable and load management strategies early, selecting the appropriate measures, and then documenting that for compliance and showing your credits that are there. There are still mandatory requirements if you're using a performance path for the code, for the commercial code. So when you're modeling the building rather than follow the prescriptive path, you have two hurdles that you need to jump over. A, you're going to have to do the mandatory prescriptives from this table here, 407.2 parentheses 1. Also, a minimum performance reduction relative to the reference design also needs to be met, which is also per table. It's parentheses 2, not 1. I don't show that on the screen. It's also important to note that on-site renewables cannot be used to dodge the reduction target beyond 5%. So while the performance path offers flexibility, compliance still demands meeting the base requirements. That's what these mandatories are here for. And then building specific. So C407.4, the 2024 IECC emphasizes that when you choose the performance path, you must detail and commit to the actual building specifications, basically covering everything from insulation to glazing to the equipment efficiencies to the controls. The modeling must reflect those specifications, and during construction/document review, you'll need to verify that the implementation of these systems match the modeled ones. So we get this, I get this a lot from people that a model is built, it's handed in for permit, the permit is given out, and then the building is built completely different. So it is clear that once you see that this modeling is done, you should follow that in the field. So for construction, documentation, commissioning, all of that's verifying that it actually meets what it was modeled. This prevents what we call model to build drift. It basically ensures the predicted energy savings from the simulation are credible and that actually was been installed. Mechanical and service water heater system commissioning. This is another one that's come to light a little bit. I've had a few jurisdictions reach out to me about how do we handle this, or third parties saying, does this city require commissioning? And if so, is there specific paperwork? So I commend any city that's already gone through this, but those that have not, there's now commissioning requirements in the commercial side. So another form may be needed to have someone sign off and document that they've done commissioning. There are a few cities in Texas that have done that already. But this section basically strengthens the commissioning report for both the mechanical and service water heating. Projects must develop a commissioning plan early, execute what's called functional testing for all major equipment, and then provide documentation, preliminary and final reports that verify the system performs as intended. Note that the update exemption threshold from the building is less than 10,000 square feet with a combined system capacity of 960,000 BTUs may be exempt. But for designers and owners, this means coordinating commissioning early with the project, identifying who that is, who's going to actually be responsible for that, who's going to sign off on it, and who's turning in documentation for that. But looking at budgeting time, documentation, and testing so code officials can verify this compliance before a CO inspection is done. All these things have been check marked and dotted off that they're completed and that commissioning's been performed. We just mentioned this term, it's functional testing is now a section here. Basically, it just says it mandates that basically key control systems, not just equipment, also needs to function and test. That's lighting controls, that's occupant sensors, that's time switches, daylight response controls, automatic receptacles. These things now must also be commissioned. So verifying that all of these are programmed correctly on a schedule and or also function as intended, like occupant sensors. These tests must be documented. The results must be included on the commissioning report. Basically, this ensures what the design and that they are actually designed and specified and actually meet the requirement of what was said to be specified on the planning report. So that's going to make sure that I've not done one like this. I don't know how hard that's going to be, but if you have an occupant sensor, that's easy to do. But if you have a daylight control, it's got to reduce its per certain power when it needs to, when daylight's strong enough to the outside. So somehow those will have to be tested either in an override system setup and or other means, but it needs to be shown that it's being commissioned. And then there's something new to this, which is basically HVAC TSPR compliance. With that part of it, I think on the next section I'll go through what that means. So this section basically introduced a major shift for that they can achieve performance or compliance with the IECC. Rather than just meeting the component efficiencies, basically this path is going to ask how much annual heating and cooling load do you serve versus how much energy the HVAC system consumes. So if you're in an applicable building, in other words, if your building's not exempt from this, and you're using that type of, your HVAC system falls under an eligible list, you need to choose from paths. Basically, you need to understand the definitions of it, what it needs to look like, and then make sure your simulation methodology is correct, and then model both the proposed system and the reference system accurately. So it's a performance-based approach that promotes holistic system efficiencies rather than a piecemeal component compliance. It's another way of looking at the efficiencies of that. And then existing buildings, I'm just going to turn through this one. There's just a few changes with that part of it. So when addition and major alterations are performed, we must now earn efficiency credits with that as well, similar to new construction. This ties into older buildings with the same performance network or same framework. It ensures that even partial projects contribute to overall energy savings. It is addressing renewable systems that are added to systems on the building, such as rooftop solar. They need documentation, or if you have off-site renewable energy, you need documentation. And then, of course, there's now an EUI, which is energy use intensities. So when the occupancy type changes, for example, converting a warehouse to an office space, the building system must meet the new construction efficiency requirements associated with that. The EUI table helps determine whether the updated systems comply with the appropriate energy intensity levels. And then there are appendices to that as well. There's a 2030 glide path. There's the required HVAC TSPRs. There's energy credits. There's vehicle charging stations. There's electric ready for commercial provisions. There's also demand response controls. So if you have any buildings that are wanting to achieve those or already doing those in their plan stages, there is appendices that can be adopted to where you actually are using those to show compliance. And then next step, as I put on here, you are here. As we heard earlier from Jonathan, we're at the level of today. We're starting the request for comment. So that's stated earlier, but SECO's adoption process ensures its transparency, its public involvement, consistency, allowing local flexibility, and maintain statewide efficiency standards. I did put a QR link on here, or the link directly if you wanted to copy and paste, or I guess you can't with a webinar. If you wanted to jot that down, take a picture of it, or use the QR code, you go directly to the SECO's Texas Energy Code adoption page for further updates on the process. They're going to have other additional information as it goes through the process itself. So I want to thank SECO for putting on or having us do this for them to go through it. I want to thank everybody that's online today. I did talk really fast, got through a lot of information. I do see a lot of questions in the chat and the Q&A. I'll go through those in just a second. But as we continue to support local officials, contractors, and energy professionals across the region, we invite you to stay connected with us. Follow us on LinkedIn. We're also on Blue Sky. There's our main number that's shown there. That's our X link as well, and is on LinkedIn as well. So we look forward to helping anybody with supporting that. And then this is my contact information. Before we wrap up, I want to thank everybody on the call today. Again, I'm not going to end it yet. We'll go through the questions in just a second. If you need help with training support, if you need help connecting or talking with city organizations, use us as a resource. Spear's here to help. So whether it's a technical question, permitting discussion, assistance, we talked about forms as well. We can help with some of the forms that are being used throughout other cities in Texas. We can help navigate those, as well as amendments that other cities are doing to help lessen the impact with adoption in your city. So that was pretty much the webinar for today. I'm actually going to sit here a second and go through some of the questions. There are some comments in here, so I know that we've got others on the call that's going to be able to read some of the comments. No, they probably can't. So one is, let's see, addressing gas and big houses, looking at possibly amending that and not using the penalties. Of course, that's going to be up to SECO and the amendment, and looking at that'll be something you can put in a public comment. Will these slides be made available? Yes, I can send out the PDF for that. This is probably going to be a very large file, so I'm not sure if I'll have to break it up into different sections. It will be uploaded, as I said in the very beginning, it will be uploaded to YouTube. You'll be able to see this a little bit later. Attic knee wall, air barrier. When you say behind the wall, do you mean on the blind side of the wall? Yes. So that's the back side facing an unconditioned space. So six-sided encapsulation, whatever you've got for interior air barrier like sheetrock or wood, then you've got a backside air barrier that's facing the unconditioned space. Sampling for testing and not inspection. That's a good question, Jason. I'm not really sure. It doesn't specifically say that. It just shows sampling protocol for the testing requirements. So you're probably right. Not the units will be inspected even though they're not being tested. It's a great point. There's links in the chat as well to actually go to the adoption page. If multifamily building is designed and sealed by an engineer, is manual J or manual S&D required? That will, of course, will be up to the city's jurisdictional having oversight to say if that's allowed. I do believe that code does allow for someone like an engineer stamp could override some of those, yes. Jason, I hope I answered the HB 3215, meeting the requirements that Texas is still under that adjusted ERI number. Mooj, good to see you. When determining fan efficacy compliance for AHU, which method is correct for following scenario? I will actually probably copy and paste that, and I'll get with you without having to go through that now, Moosh. I'm going to go ahead and copy that, and then I'll save that for another one. And then Stephen, with the tighter air leakage thresholds in 2024, are you seeing builders, HVAC contractors start using aerosol-based air sealing technologies like AeroSeal to meet targets? Yeah. Actually, I've got somebody that I know that's with AeroSeal. They may or may not be on the call, but they're getting a lot of phone calls. It can satisfy two different requirements, just like foam, but you're not using foam. You're air sealing. Well, not really. It's not insulating it, but it's air sealing it tightly, kind of like what foam would do, and then you're insulating on top of that. But yeah, to answer your questions, there is some of those people asking those questions. I see them more at trade shows as well. So I know that they're out there. Oh, Michael's here. Good to see you, Michael. So yeah, I hope I answered that question correctly. But yeah, there is a lot more demand coming up for that as well, since the ACH is going to be dropping. Just keep in mind too that Texas is still home rule. Your city is jurisdiction that you build in may not update or will not or could not update the adoption. What we went through today is what Texas is looking at as a whole. So rural areas outside of jurisdictional oversight will be under a new code if they adopt it and the process goes through. But each city will have their own code and amended code. So they could technically still be under, let's say Dallas, for example, is under the 2021, but Texas goes 24. Dallas could either move to the 24 or remain on the 21. So just keep that in mind. So in new construction without foam, will the air handler be allowed to be installed in the attic? Yes. There's nothing against that at this point. Jonathan's put another link in the chat. All right, any more questions with that? Again, I'm here to help with questions, answer questions, go through questions, help with things, do trainings. Spear is happy to help with that. How is the payback period or ROI including with these changes? Does ESL look at that? Yes, Joseph, they do. There's a lot of questions that come up about that. There are a lot of reports that are out there as well. There's a lot of estimates that you get from different organizations. Some are way out in left field. Others, I think, are more structured to where they make sense. But a lot of that, of course, being if you've got performance or ERI as a pathway, those payback periods can move all over the place. It's just a moving target. If you look at a home from 2015 to 2024, but you're looking at prescriptive only, that ROI and payback could be rather wide. But if you're now looking at a 15 to a 24, but you're using performance and you've narrowed down and fine-tuned your construction, that ROI and payback may not be as far out as you think it is. Hope that answered your question. And of course, a lot of it, Texas is still under the 2015, but the majority of states, we have it posted on our website with a spreadsheet that you can look at. The majority of cities, I think, well, 30% of them are on 2021. We've got close to 20 or 25 now on the 24. And we've got another 25% on the 18, and then the rest of Texas is on the 15 or even earlier. But the majority of Texas has moved to a newer energy code beyond that 2015 code. So saying, well, going from 15 to 24 is a huge difference. That's true. But if you're building in major metroplexes or even cities that are larger than, in my opinion, 20,000 people, they're probably already on a newer code, so you'll have to base it off of going from an 18 to a 24 or a 21 to a 24, which is going to greatly reduce and shrink that payback period. That's a great question, Joseph. Thanks for bringing that up. All right, so we are done a little bit early, and I thank everybody for being here today. We will end it as we wrap this up today. I thank everybody for being here. If you have any additional questions, please keep my contact information. Reach out to me with any thoughts, questions, comments, feedback. We really appreciate it. Thanks again for being here.